Okay, we're rolling. So I've got sodium chloride first. Oh yeah, just a little more. So sodium chloride and concentrated sulfuric acid, which is kind of an oily brown liquid. You can see that in the camera. There we go. And I've just put a squirt of that in. It can just help to have a black background for this one, because what we're looking for is little puffs of white misty fumes. Can you see those coming out of the top of the test tube? So those white misty fumes are
Hydrochloric acid.
well, actually they're hydrogen chloride. Yeah, hydrochloric acid has to be dissolved in water. Hydrogen chloride gas is the white misty fumes there. Yeah, but it's still HCl. Okay, so no other changes there. We get HCl given off in the white misty fumes there. Just put that there, you can see. Oh, that's nice. That's puffing away there nicely. Yeah. So while it's doing that, I'll get out the bromide. So sodium bromide does tend to get a bit lumpy, which means this can be quite hard to get out. Can you have a large beaker there for me? Because the trouble is, if you break it up and then the powder goes to the bottom of the container. Do you know? No, I'm there. But we'll leave the beaker anyway. I might need it in a minute. Thank you. Okay. So the bromide there is that white powder. I'm just going to remove that now. So we've got a white background. Add some conc sulfuric to the bromide, and just keep your eyes on it as it changes. It starts off white, and then you see a little bit of colour start to emerge, a bit of yellow, and then it starts to become a bit more orangey. If you look carefully coming out the top, you can see little puffs of white misty fumes, but then they start to become turn into the orange gas of bromine there. So it's now getting a nice reddy coloured liquid in the bottom as the bromine forms there. There are lots of brown or orangey coloured fumes coming out the top. And it's very clear change, good clear colour change forming the bromine, but it's also a very quick change. But now we'll compare that with the iodine. So notice all of these halides that I'm starting off with, they're all white solids. They're all fairly stable, fairly harmless compounds, really. We stick in the sulfuric acid. So for iodine, what we're really interested in is comparing the rate of the reaction with bromide, because we're not going to be able to see all the lovely sulfur products that you get, unfortunately, but look how quickly the reaction happens. It's in, and it pretty much goes black instantly. Lots of fumes coming out the top. Again, the white misty fumes, which are the hydrogen iodide this time. But the test tube pretty much goes black instantly as it fills up with that iodine. Don't get any particularly. Don't think we get any coloured vapour out there. I can't see any purple vapour. I can still see orange vapour coming from the bromide one in the middle there. That's still frothing away nicely. But from the iodide, pretty much instantly goes from iodide to iodine, and it's very hard to see any sulfur products there. Yeah, I'm just going to try the iodide again, just with a tiny amount of sulfuric acid, just see if we can see any of those intermediate substances. So we're just going to pop a drop in there. And what we actually see there is, you can see some of the orangey yellow colour there. That's not the iodine, that's sulphur. So and a bit of yellow creeping up the inside of the container there, that's actually a little bit of sulphur forming on the inside of the tube there. As soon as it gets hit by the sulfuric acid, the sulphur forms and then it evaporates, because sulphur evaporates at a fairly low temperature, and we get that characteristic yellow solid of the sulphur there. That's quite nice actually. Just hold that nice and close to the camera there so we can see that. Lovely. Beautiful. Lovely. That's it really. That's the whole show. So what we'll do now is we'll just summarise the different products that you get. So there's a space for this in the back of your topic booklet. So if you find the experiment at the back of your topic booklet, and we'll move to the front. I'll pause this now, and then we'll do that on the front as normal. Right. So a good way of summarising this then is just to think of so we're still on conc sulfuric and the solid halides, is just to think of it in terms of products, just simply in terms of products. So sodium chloride we get NaHSO4, that's right, which you can't really see. It will be a white solid, but you don't really see it in amongst the other white solid and frothy sulfuric acid. But we do see and we see that as white misty fumes.
So for the NaHSO4, you don't write any observations?
Well, I mean, it is a white solid, but you can't see a white solid as well as the other white solid that's already there. You can't separate it. Okay. Sodium bromide then makes the same NaHSO4, and it makes the same hydrogen halide gas, which again would be the white misty fumes. But in addition to that, it makes SO2 and Br2. Now, SO2 isn't a gas that we've had much experience of. Oh, is that tap still on? You just I've left the tap on, haven't I? You just turn it off. There's that green light there on the front. Thank you. Awesome. But actually, the SO2 appears as white fumes as well, which means it's quite hard to distinguish from other white misty fumes that are there. But the Br2 is much more obvious. So that's either a red liquid or an orangey brown gas, seen in the test tube there. And then for the sodium iodide, well, we're going to get the sodium hydrogen sulfate, and we're going to get the hydrogen iodide, white misty fumes, and we're going to get the SO2 white fumes as well. All of that's going to happen. But as well as that, we get the iodine solid, which is, what colour is iodine? Black solid.
Grey.
Yeah, it does appear as a sort of greyish or sort of silvery grey black, I think, is sometimes how it appears, isn't it? Okay, the sulfur then. So we got a little bit of that sulfur in that last experiment. Sulfur. What's the appearance of sulfur?
It's like white.
It's not white.
Yellowish.
Yellowish.
Orange.
Yellowish. Can't just be yellow, it's got to be a yellow thing.
Yellow orange.
Yellow orange what?
Oh, gas. No, it was a liquid.
It's a solid.
Oh, is it?
Sulfur's a yellow solid, yeah. And we might be lucky enough to get some H2S as well. Say lucky, not really lucky. What's H2S's most, hydrogen sulfide's most distinctive property?
Isn't it colourless?
It is clear, colourless gas, yes. Smells of?
Egg.
Yeah, rotten egg. So really repulsive smell. It's you know, if you ever see in a crime show and they find a body and maybe the body's been, you know, rotting a few weeks, perhaps in a plastic bag or something, and it's just disgusting, and you know, you see the detective kind of throwing up. That's hydrogen sulfide again. It's a really disgusting smell. It's also quite poisonous, but it doesn't usually matter because our noses can detect a few molecules of hydrogen sulfide. We're really sensitive to it, which you can see in terms of evolution makes sense, because if it comes off rotting food, rotting meat, well, you want our bodies to tell us to not go anywhere near rotting meat, because obviously it's going to be contaminated with all kinds of nasties. So usually we smell hydrogen sulfide and get out of there before it can do us any damage. Okay, so what you really need to remember for these reactions is the products. So if you can remember that NaCl stops at HCl, and NaBr goes as far as SO2 and bromine, but NaI goes all the way to sulfur and hydrogen sulfide. You can actually fill in the rest of the gaps yourself in the exam by balancing a couple of half equations. But obviously you can't do that if you don't know what the products are. Okay. Stupid camera there.